everyone, welcome back to my channel. The new video. In this video is starting with hash maps, one of the most important topics for data structures and algorithms. And if you don't already know, we're doing the complete data structures, algorithms and interview preparation bootcamp. So the link to the playlist, to the course can be found in the description below. You can check out the previous videos as well. And the best way to support is to like, share and comment and subscribe if you haven't already. But hash maps, very important topic. I know I say it with every new concept, like, okay, this is the most important topic, but yeah, hash maps is very important topic, because hash maps, the concept of hash maps is used in other sort of problems. It may be used with trees, with the dynamic programming, with sorting, with heaps. It is used quite a lot with heaps as well. And we've covered an introduction to heaps, so we'll do hash maps. We'll do some nice questions in another video, but this video is about hash maps. So we'll learn what are hash maps, implement from scratch, see a lot of theory around hash maps and around various ways via which people implement hash maps, some of the limitations and the solutions to those limitations. So I'll tell you a lot of theory part, but there will be a lot of code part in this video as well, because we'll be implementing various versions of hash maps ourselves, and the code can be found in the description below, the code that I'll be writing, so you can run it on your browser easily and check it out as well. So yeah, code sample and everything in the description below. Also the notes and assignments and everything can also be found in the description below. And yeah, I'm very excited because this is a very fun topic. I love hash maps, and this video is more than enough for you to learn about hash maps and how they work and everything. Next video we'll do some questions. Let's get started. Okay, so let's start with hash maps. The code and the notes that I'm writing will also be found in the description below, but what I just recommend is just watch the video. You don't have to make code, because don't have to make any notes, because it will be available, like the lecture will be online and you can Google search whenever you get in a doubt. But still, if you want, you can make notes. The most important thing is that the video will be available online all the time, okay, on YouTube. And then you can revise anytime, and all the important things I say, you can make a timestamp note or whatever. That's one of the best ways to go ahead with it. But yeah, let's get started. Hash maps. So as you know, I always start my lectures like you don't know anything about hash maps. By the way, if you have been following the data structure algorithms bootcamp, please do that, because we are continuing that series. So in the previous sections, we have done binary search trees, we have done heaps and all sorts of things. So with binary search tree, we can get element or whatever in O of log of n time. Binary search tree, very simple. We've already done this. But now the question is, what if I want to get stuff in constant amount of time? I have inserted 1000 elements in a data structure, and I want to get that in constant amount of time, in just one step. Okay, no searching, nothing needed, no traversal, no loops, nothing. Okay, so there are various ways to store items, right? So if you store number of items in like an array, you store many items in an array, and you're like, okay, try to search for an item which is so on and so forth. Try to search for 14. So what do? You just start traversing. I'll start checking from here, and I will keep looking where the item is. This is what? This is O of n time. We all know this. Binary search tree, we know. With binary search tree, we'll do O of log n time in order to search. But the question is, I want to search in constant time. If someone tells, search for this element in this data structure, no traversing, nothing needed, no for loop needed, I need to search it in constant time. How can we do that? We can do this using hash maps. First, we will look at why we are using it, and then we will look at how it works. So don't worry about the internal implementation right now. I am telling you, you can access in constant amount of time. Yes, take my word for it. Believe me. How we are doing it, what are the mechanism behind it, how it works internally, we will look into this video only, so don't worry. Okay, so for now, we know hash maps, we can access data in constant amount of time. Okay, how do we do that? No idea. We will look at it later on. But for now, we know constant amount of time. So the structure of hash map is sort of like this. You have key value pairs. you have a key and you have a value pair. So for example, key represents the name, value represents the marks. For example, this is, let's say, what a hash map is. Key value pairs. One entry in the hash map is Kunal. Kunal is one of the keys. Value is 88. This is actually how much I got in my computer science exam in high school. So people often ask me, Kunal, were you really good at coding when you were a little kid? No, I got 88 out of 100, which in India is not a very good. So I started coding seriously in first year of college when I was like really upset for not getting in a good college. Before first year of college, I was very careless about studies. So I was not the best person in my high school for coding. It was actually Karan Singh Bora, my good friend. Shout out to Karan. But Kunal, 88 marks, that is one element in the hash map. Again, don't worry about, Kunal, how is this key value being stored? No, don't worry about it. We will look at the internal implementation. For now, just take a look at it in a diagram form only. Let's say it's being stored in a diagram form. How it is being stored, what is the internal implementation, how is it made? We'll take a look at it later on. Okay, what sort of data structure and stuff is used to create hash map. Don't worry about it. Just theory part, okay? Focus on the theory right now, not at all about the code implementation, please. Because I know people get worried about it, okay? Forget the code part. Again, for like, I don't know, I'll keep explaining this. It will take some time, maybe 1 hour. I don't know. I'm recording live. So forget about code till I mention code, okay? No code needed right now. We will look at theory and how it works and everything. Let's say you have a key and a value pair in one entry of one element of a hash map. Okay, so first element is consisting of a key value pair, which is Kunal, 88 marks. We have Karan, 99 marks. We have Rahul, which is 95 marks, so on and so forth. So this hash map here has 3 items, these 3 items. And every item has a key and that key has a value. Okay, let's say the reference variable of this hash map is map. So you can say map.get and I can pass Kunal over here. This will return the value which is equal to 88 in constant amount of time. Constant time. I search for Rahul. I say map.get Rahul. Hey map, give me the value of Rahul. Map will be like, okay, the value of Rahul is 95. Map will not be like, okay, let me search first Kunal. Is this what the user is asking? No. Move forward to the next. Karan, is this what user is asking? No. Move forward to the next. Rahul, is this what user is asking? No. Yes. Then it will give Rahul. No. That is not how it works. There is no traversing. Directly it will jump onto Rahul and it will give me that answer. How? Don't worry about it. We'll cover it later. But that is what it's doing. That is what it is doing. So I hope you are able to understand what HashMap is doing and how it's like actually giving me the answer and how we're trying to store it in HashMap the data in a theory sense. In a theory sense. Okay, let's move forward. So what are some of the real world like implementations of HashMap? Why are we using HashMaps at all? It's used in a lot of places. So in like compilers and interpreters for like C, C++, Java, Python, whatever, it is used there as well internally when the programming language is built to point the names to the variables. Okay, when you're like, hey, print A, and it will like A is equal to, okay, 10. So that value, internally how the programming, this is too in-depth, but internally what I'm saying is, it also uses hash maps when forming the programming language. A simple example I can give you is network routers. So routing the IP addresses, that also uses hash maps because you need access in like constant time. And for network servers, you have the port numbers that directs to like your socket or your application. Virtual memory. So for example, sometimes you create virtual machines or your virtual memory that is linked to physical memory or whatever, right? And yeah, so many places it's being used. Now, other places it is being used in like also in cryptography. That is where hashing is used quite a lot. String search, grep, for example, if you use the grep command, that uses hash maps. Okay, so a lot of places where maps are being used, hash maps. Okay, so let's see how this actually now works. Okay, now let me explain it to you in a very simple way how it works. So I'll explain theory first, we'll do code later and everything, but please try not to get confused. I request you, it is not that complex. Just think about what I'm saying. Okay, let's say we have a hash table. We have a hash table. Let's say it's in the form of an array. Okay, we have a table like this, let's say in the form of an array. Let's say I have an array like this. Okay, let's say I'm storing it in an array. Let's say the idea is that it contains some elements and I'm like, does this element exist in the array or not? Give me in constant amount of time, or better, just return the index where it is stored. So if this contains, let's say it contains Kunal, this contains Rahul, this contains Sivo, and I'm like, give me the index of Sivo. It will not search. It will not be like, okay, is this Sivo, is this Sivo, is this Sivo, is this Sivo, is this? It will not do linear search. It will give me in constant time. It will be like, okay, Sivo exists. Yes, that is true. Sivo exists. How? So how do we do this? So the idea for hashing is, one thing you have to understand is the concept of hash code. Now hash code is nothing really. It is just a way of getting a number, an integer. Okay, you give it anything. It can be an object, it can be an integer, it can be a name, a string, a character, a float, whatever you want to give it, you give it to the function and it will create a number out of it using some formula. So two problems arise over here in this scenario, that in the array, which is the keys have to be integers. Because sometimes you're like Kunal, so you're like, okay, Kunal, you need a number for Kunal. How are you going to convert Kunal into a number? You use the hash code function. Okay, so problem 1, we need all elements as positive numbers. We use the hash code function. I'll show you in just a minute. And I know it's confusing, so don't worry, I will explain it in more detail what I'm just saying. So bear with me for 5 minutes. The second problem is the hash code that I get can be very large. So the idea is reduce it. Okay, this is known as hashing. Okay, so what I can say is that reduce, I'm not going to write it. No, I can write it. It reduce all elements in table to a size m. Okay, so what I mean by this is, let me just give you an example. Let's say initially it's empty. Now let me explain it to you. Let me explain. Let's say initially the size of the array is 1, 2, 3, 4, 5, 6, 7, 8, or I can just say 9, 10. Initially, let's say the size of the hash table is 10. Internally, it's an array. Now I'm like, hey Kunal, please insert the word Sivo in it, in the hash table, which is formed like an array. So you're going to be like, okay, this is actually not an integer. I need to convert it into an integer. So I will be like, give me the hash of Sivo. Java is going to be like, okay, this is equal to, let's say something like 83 479. 83479. Now this is a really big number. This index, what you can do is, let's say for every what you can do is, let's say, okay, I got an idea to explain it to you. Okay, let's say initially the size is equal to 10 of the array. Let's say the hash of CVO is equal to giving me a number 7. Please don't get confused with hash. Okay, it's just, let's say, a function in Java. It may not be called hash. I will tell you what it's called. You just give it anything, it will convert it into a number. Now why does it matter how it converts it into a number? Maybe it's taking ASCII values or whatever. Maybe if you say hash of 20,000, it will give you what? Some other number. Maybe it will be 20,000, because I think to a particular number, the hash of a number, it's the number itself. You're not understanding. Let me first explain to you what hash number means. Let me just show you the code. Give me a second. Let me show you a code. Java HashMaps I'll explain this later, okay? Don't worry. It's very simple, don't worry, I'll explain it to you in just a minute. Hash code returns the hashed code. Okay. I'll just explain to you what hash code means. Give me a second. Okay, so here in the object class, there is a hash code method over here. So it just returns the hash code value for the object. If you have done object-oriented programming, then you know that I can run it for any, because object class is, the parent class. All the other classes are inside the object class. So if I'm zooming in, as you can see over here, if I run it again, so it's like name Kunal. What is the hash code of Kunal? It's saying 7285847. Now you'll be like, Kunal, what is this? Is this the reference address number? No, it's a random, it's an integer. That's it. Not random, because there's some sort of method. So for example, I can say string class hash code, Java string hash code. If you want to see the internal implementation, Stack Overflow. Like this. Okay, so maybe if you ask for hash code, it will be like taking the ASCII value and doing some calculation, and doing some left shift, right shift, whatever you want to call it, some addition, subtraction, and then converting the string into a number. You can just check the official Java docs if you want to look at it. Okay, similarly, if I say Rahul, it will again take R, ASCII value of R and A and convert it and merge it and do left shift, right shift, whatever you want to call it, and then give me a number. Here you go. Okay, so if the value is same, the hash code will always be same, because behind the function it's only a formula. Please don't ask me about object class, okay? I will get very angry. I have explained like a complete object-oriented programming playlist. If you're asking me, Kunal, how are you doing name.hashcode? I can't help you. Please watch object-oriented programming playlist. Okay, because this is an object class method. So I'm applying it in every other class I can apply. I can do it integer also. If I'm saying int a is equal to something like this, what is going to be the hash code of this? Usually the hash code of a number is the number itself to a particular value. Exact answer you can find in the Java documentation. So the hash code of 4235678 will be 4235678, because this is a unique number. This is a unique number. Hash code I use hash code. Why? Because I want a unique number value, and every number is a unique number. So what is the point of changing this number into some other number? It will give the oh, sorry, that was a primitive. There we go. Same number itself, I can run it again. See, same number it's giving me. Okay, this is what hash code is. Give it anything, it will convert it into a number. Okay, so moving on. Here if I say hash code of CVO is let's say 7, so I'm going to be like, okay, just insert it into index number 7. So here I will add CVO. I will say hash code of Kunal is equal to, let's say it calculates and give me another number called 3. So I'll be like, okay, I will add Kunal over here. Hash of Rahul is going to be equal to, let's say 2. I will add Rahul over here. Now when you try to get the item, I will like give me the item Kunal. It will be like, okay, let me just calculate the hash of Kunal. Hash of Kunal is coming out to be 3. This because is a mathematical formula, so it will be, let's say, constant time. We can say, okay, don't go into too much details. I know some people who are over smart, they will be like, oh, it's not constant, it's average constant time. No, you are also wrong. It's called amortized constant time, which I will explain later. For now, just think constant time. Okay. For now, let's imagine it's all constant time. The hash function. It's giving me 3. So in constant time, you will be like 3 and you will be like, okay, yeah, it exists. So that's how we are solving the problem of getting stuff in constant time. But the reality is that this number is not one digit number as you just saw. It's giving me a lot of bigger number. If it's giving something like this, for example, what will you do? If it's giving me a really big number, it's not giving a smaller number, it's giving a really big number. But the size of my array is 10. So now we can do hashing. Hashing basically means if you're getting like larger numbers, okay, you're getting some bigger numbers, you can either do something like this number itself in the index of this number. So have the array of the size of 7,34,985. No, not good. I want to insert all these items in the size 10 only. But yeah, that's what I want to do. So we want to insert CVO. It will be like, okay, let me calculate hash of CVO. It will give this number. Now where to put this number? So now it's known as hashing. Hashing now basically means we are trying to reduce all of these numbers in the format of, let's say, size 10. So all the numbers should come less than 10. So how do I create all these numbers less than 10? I can just take remainder with 10, modulo 10. Can I not do that? If I take any number, let's say, see, 734,985 modulo 10, getting me the remainder, which is 5. This is coming out to be 5. So CVO will be here. Similarly, this modulo 10 will come out to be 7. Kunal will be here. Modulo 10 will come out to be 3. Rahul will be here. Simple. Now also is constant time only, because hash function getting me the number in constant time and I am reducing that number into a smaller digit of size 10. Not a problem. Simple. Very easy. How are we doing it? Okay. But now you will be like, Kunal, would it not be possible that sometimes it may be possible that 2 items, even though they may not have the same hash code. Now you'll be like, Kunal, how do you know they will not have the same hash code? Prove it. I will prove it. Okay, don't worry. I will not let it go. But for example, let's say after you do the modulo, there can be, let's say if I do if I do something like hash of armo, this is coming out to be 39478 Now I do modulo 10, it's giving me 3. So at index 3 I should put armo, but now at index 3 Rahul is already there. What do I do? This is known as a collision. This is known as a collision. When you get multiple indices as same, that's known as a collision. There are ways to deal with collisions also. Let's see. Okay, so how do we deal with collisions? And by the way, this how I got like these are known as hash functions that I have over here. The hash function, like this hash function is just modulo by the array size. Okay, but there are multiple hash functions that we'll look into it right now. So collision, two ways to resolve collision. Way number one is chaining, and way number two is open addressing. Okay, sounds good. So what is chaining? Chaining basically means, let's say I have an array. At every element in the array, let's say there is a linked list. I want to insert Kunal. Kunal will go over here, let's say in the linked list. Kunal. Then I want to insert Rahul. Let's say Rahul goes over here. Sivo goes over here. Then I have armo, and let's say the armo hash, so getting the hash of armo modulo by the array size is giving me the same number as Kunal. So I will not replace Kunal. Since it is a linked list, I will add armo over here. Let's say I take another element that is also adding in the same number. So it will be like, okay, now another element, let's say PS5, something random. Okay, sounds good. So you can see the worst case here is, Kunal, what if there is a possible worst case that all the keys belong to the same element only? Let's say you're inputting 10 names, and all the 10 names, when you get the hash value, hash code of it, and modulo by the array size, it's giving you 3 only. So it's going to be like one n size list, linked list. Because if you want to search for armo now, it will be like, okay, get me the hash of armo. It will be like, okay, after the modulo and everything, it's giving me 3. So at the third index, I will start searching. Here I will traverse. Is the first element armo? No. Is the second element armo? Yes. That's how I will get it. So even though at this index I am getting in constant time, there is a traversal here. So in the worst case, let's say worst possible scenario, let's say your life is like very panoti, which is a Hindi word for bad luck. Every item you're inserting is giving the same index value. So you'll keep on inserting in that linked list. Yeah, that will happen. Okay. So how do we solve this problem? How do we solve this problem? How do we solve this? So we try our best. How do we solve this problem? We try our best that not all the elements come on the same index all the time. We try our best. So this is known as, we cheat a little bit. We cheat a little bit. How? We use simple uniform hashing. I know this is the doubt people have, but Kunal, what if all the hash code that you get and divided by the array size or whatever hashing function, whatever the hashing function gives me the number, what is that number is 3 all the time. All the time, let's say it's 3. Yeah, that is possible. In that case, your whole HashMap point of view is gone because it's no more constant time. So we cheat a little bit. It is known as simple uniform hashing. we make an assumption. We make an assumption. The assumption is that every key is equally likely to be hashed to any slot in the table, independent of where all the previous keys are hashed. Okay, so if we say n is equal to what? Total number of keys in table, m is equal to what? Size of the table. Then the load factor, which is equal to alpha, is going to be equal to n divided by m. But what does this mean? This basically means that, say, if you have n number of items you want to put in the hash table, total slots are m, then n divided by m is the expected keys per item. Okay, expected number of keys in per slot. Per slot. Because we are making this assumption that every key is equally likely to be put in every, so the probability we are saying is, we are making an assumption that the probability if you enter a new key, the probability that it will go in the index number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the indices, any one of the indices it will go to, the probability is same. Okay, so let's say the size is 10 and you are inserting 20 items, then we are saying that we are expecting at least 2 items in one index, because 20 divided by 10 is 2. Okay, so what does this mean? If we are assuming, it means that the time complexity now is equal to 1, O of 1. This 1 is for the hash function that we applied and got into that point. And now for the linked list, it will be, what is the maximum size that we are assuming of a linked list? Alpha. Assuming, please, we are assuming over here that maximum it will be alpha. Okay, this is for the list, linked list. I will prove it a little bit more, okay, don't worry. Okay, and if alpha itself is equal to O of 1, means constant time, then this also comes out to be constant time. Okay, and this happens when the size of the table is equal to big omega of n. If you don't know what big omega means, time complexity lecture, check it out. So I hope you are able to understand what I mean by assumption. We are assuming that every item that I put, you are putting Kunal, Rahul, Armo, PS5, Sivo, it does not matter what the items are already in the array. It does not matter. The probability that Kunal or Armo or any other new word that I want to put is equally likely to be in any one of these indices. It's not like, okay, index number 3 we are assuming is higher chance, index number 4 we are assuming in higher chance. Here let's say I say index number 3 is higher chance because it already has 3 items. No. For every item I'm assuming that the probability is same, that it will lie in any single one of those. Okay. Now when we talk about the hash functions that is used to achieve this thing, hash function, let's see. The first hash function that we have seen is the division method. Okay, so the hash value, key value, the where I will put it, index value of a key k is going to be equal to what? K modulo m. Okay, now this can be anything. This can be like your size of array, for example. But the size of array, it's like not very efficient, if you will, in terms of like, okay, it may give, let's say it's not very that much random. So what people do is they sometimes take m is equal to a prime number. Okay. Why? Because it will give you more random generated answer, but not too close to the power of 2 or 10 because these are common in the real world. Okay. Sounds good? This is one of the hash functions that we have already looked into right now. There's another way, multiplication method. What is multiplication method? I can say that the hash key of a key k is equal to, I can say the formula a multiplied by k modulo 2 raised to the power m shift w minus r. Okay, here a is equal to random number. There's nothing to be confused over here. This is just formula. Scientists and people, they have created these formulas. Not a problem. Okay. W is equal to number of bits in k. Okay. And m is equal to, I can say not m here, this will be w over here. And I can say one more relation is m is equal to 2 raised to the power r. Okay. Many times multiplication method is used because multiplication here is faster, the bit operations, than division. And this is just one of the popular formulas that people have to calculate the hash value, where the item will go. Okay, this is practical when a is odd number. Okay, and 2 raised to power w minus 1 is less than a is less than 2 raised to power w, and also a is not too close to 2 raised to power w minus 1 or 2 raised to power w. So this will give us a very random number, and that's another function that people can use. There's not much to explain this. This is a mathematical formula, and in interviews no one is going to ask you to generate this formula or code this formula. But if you want to code it, it's very easy. But no one will ask you much information about this stuff. In a simple way, we've learned about the division method, but I hope you understand what that means. So it's very simple. Again, don't be confused. It's just a math formula. Okay, don't be confused. Okay. Now, moving on, another method of hashing that I want to tell you is universal hashing. Right now I'm just telling you how numbers are converted into like the indices and stuff, so the hash value. So here I can say, for example, hash for a key I can say is equal to a into k plus b, okay, modulo p, where I can say also modulo m, and here I can say that a and b are random numbers. This much is much simpler. Okay, this formula that belongs to, can say 0 to p minus 1, 0 say to p minus 1. Okay, so this is a very simple formula. You give it a hash of k for a number, let's say for a key, and it's going to be like, okay, multiplied by a plus b modulo p modulo m, so on and so forth. P is also a large prime number. P is a large prime number. Okay, sounds good. The reason I'm sharing is because using this formula, it says using this formula that the probability that if you have two different keys, then the probability that hash value of key 1 is equal to hash value of key 2 this is equal to 1 divided by m. Okay, using this formula, this is what the probability comes out. We were talking about what if we do multiple numbers, multiple items, and they have the same number. So the probability for that here is 1 divided by m. Okay, so moving on, we have just learned about like some basic functions. We have not even started hash maps in Java yet. Okay, I will show you the interface and map and everything, but it's important to learn about the internal details. Okay, doubt you will be having. The doubt you may be having is how much should be the size of the table. Okay, you said initially we took random 10, for example. How long should be the size, and what to do if, let's say, you are having a finite size of the table. First of all, you have 10, then you keep inserting 1000 elements in it. Obviously, we know chaining will happen, obviously, because slots are 10 and you have inserted 1000 elements. So how do you make sure what the size of the array is, how large the table should be? So size of the table. You want the size of the table to be theta of n all the time. Okay, again, theta we've covered in space and time complexity. Right, and if you have the size as very small, then it means that your table will be slow. If you have it very big, it means that you are wasting resources. Wasteful. Okay, so the idea is start small and then grow. Okay, cool. So the idea is, let's say you have 5 elements at first. And you have just inserted 9, 8, 3 and 5 here. And you've inserted 7 here. So there are 5 elements, and let's say you have inserted, the size is 5 of the table, and you have inserted 5 elements already. So after the table is full, what you do is you double the size. So you will now create 10 elements. You will add in the items 9, 8, 7, 3, 5, and then you will add in new items. Okay. So you can double it, or you can, let's say, increase it 1 by 1 also. If you increase it 1 by 1, let's say when number of elements becomes equal to the size, you, let's say, increase the size by 1. So at every step, what you're doing is you're increasing the size by 1. Increase size by 1, copy all the elements, then add in a new element. Increase size by 1, copy all the elements, that and add a new element. So n inserts will cost how much? O of 1 plus 2, because you're inserting the elements again and again, copy, pasting, 6 plus 7 plus at every step 8. For nth element, you will be doing n operations, because copying it n time, then adding a number 1. Okay, this comes out to be what? Sum of n numbers, O of n squared. So in order to add n elements, you are doing O of n squared, time complexity. So better way to do is multiply by 2, means double the size. Okay, so what do we mean by double the size? Do size equal to 2. Okay, table doubling. And the idea is that, let's say you have one item. So you just insert in one item in the array. Now you want to insert another item. So what you will do is you will double it, and then you will insert another item. So if you double it, it will take 2. After that, third item will just go there. Fourth item, you have to double it again, and So for example, initially let's say you have just 1. So you added 1 over here. Now you want to insert 3. So it will be like, okay, it is full, so I will double it and then insert 3. Okay, you want to insert another item. Let's say you want to insert 4. So what you'll do is you will double it again. Now you inserted 4. Okay, then you want to insert 5. Then you want to insert 6. So if you want to insert 6, you will double it again. You will insert 6. So this double cost what? 4. Then you want to insert again. So at every 2 raised to power I, you are doubling. Very simple math, right? So for n till n, this is going to be equal to what? If you want to insert n elements, this is coming out to be O of n. So to insert, so in simple terms, when you double the table, cost to insert n items comes out to be O of n because of this formula. Because of this thing, okay? This is very simple, just simple maths, right? Okay. So n items on an average cost, let's say on an average in quotation, on an average, inserting n items cost O of n. So inserting one item is going to cost O of 1. This is known as amortized constant time, or like average constant time on an average. Okay, remember how we did array list? In array list, what was happening? Array list also internally is an array, but when it gets full or half or whatever, we double it. We double it. In that case also, inserting in array list and stuff is also O of 1 amortized constant time. We say it's constant time, but it's on an average constant time. Okay. Cool. Similarly, if the size of the array becomes, if it has half the number of elements, then I can shrink the array. Okay. Sounds good. But what you're doing is, this is also not very efficient, because this is O of n per operation. So instead, for shrinking, what we have to do is, when the size, here I can say that when n becomes m by 4, number of elements become m by 4, then half the size. Now this is O of 1 amortized time. Okay. Sounds good. Easy. Let's move forward. Okay, now we looked at chaining, one of the ways to prevent collisions. Another way to prevent collision is known as open addressing. Again, I have not looked at the code or the Java part right now, so don't worry, we will look into it later on, like after this, after the theory part. But now we're talking about open addressing. What does open addressing mean? So how do we deal with collisions using open addressing? It means no chaining. So we will use all the indices or elements like slots in the table only. We will not create any linked list or whatever. Okay, so idea here is only one item per slot. Okay, so the size should be greater than equal to the number of items. So what the hash function is going to do is it's going to probe. Probe basically means it's going to try. It's going to try to insert an item. Okay. So for example, I have an empty, let's say I have a table over here. Let's say I create a table like this. Okay, this has some items already, 139, 46, 88, and I want to insert something. So I will find the hash value for, I want to insert 33 at the first try or the 0th try. Okay, 0 means the first try. And let's say this points me to this index. So it will be like, okay, this is already available. Try something for this now on the second try. Second try, it will be like, okay, now it's pointing to this. It's going to be like, okay, this is also available. Insert 33 on the third try. It will, let's say, point to this index. It will be like, okay, this is empty. I will add 33 over here. So instead of creating a linked list or whatever, if you get the hash function gives you a value and that value index is already occupied. Previously we were creating a linked list. Now to be like, okay, we won't do that. We will look at the next possible item. That's basically what it means. Okay. Sounds good. Okay. Now, since when I'm searching for 33, right? So it's like 33, I'm searching, let's say if I'm searching for 33, then it will first search for 139. Then it will, let's say, search for 46, and then it will come to 33. Make sense? So it's going searching for 139, 46, and then 33. So if I want to delete an item, I can't just make this empty. I will have to put a pointer here or some note here called delete, like a flag I have put over here. So that when I'm trying to search for 33, it will be like 139, delete. It means that there was something here that got deleted, and after that 33. Okay, I will show you how this thing happens, how it moves. Let's look at it right now. So what are some of the probing strategies? Let's say we found an index, but it doesn't work, so it will look for other index. How will it look for other index? Probing strategies. First one is known as linear probing. Okay, h of key for the ith time is going to be equal to, it's going to be equal to what? Calculate the hash function normally. Okay, plus I modulo m. Okay, so I just calculate a hash function 0, 33, it's pointing to this. Then it's going to be like, okay, I will look at the second try, 33 of 1, whatever item was, plus 1 means the next index. So I'm linearly jumping. First it was over here, then it will check this one, then this one, then this one, then this one, then this one. Linearly jumping. So it will add item here. Similarly, I go over here, it will add item here. So it is linearly jumping. So it will, let's say, if I have like some elements like this, right? Let's say index number m minus 1, 0, h of k of I, because it's linear, it will be like in like this size or something. Okay, because I'm jumping linearly. All right, there's a problem here. A cluster is being formed. Problem is clustering. You're not utilizing all the space and a cluster is being formed. Please jump a little farther. Okay. So what you can do is double hashing. H of key for the ith try is going to be equal to first hash function I use plus I multiplied by second hash function that I will use. Modulo m, so it remains in the same size of the array. Now I'm not just increasing by linear numbers, I'm actually increasing by another factor. So it's making a more jump. Okay, cool. Right. Also, this will actually hit all the slots like in permutation if h2 of k is relative prime to m for all k. See, the thing is, these sorts of things that I'm mentioning are for people who really like maths like me. Interviewer will not ask you this. And these things are also not required, these mathematical complex stuff for data structures algorithms, not required. Okay, but for fun fact, I'm telling you, if you're the kind of person who doesn't like math that much, you can skip over it, it's fine. But I'm just saying, if you're not able to understand what I'm writing mathematical complex formulas, don't worry. Look at some of the basics, learn some basics, but you can ideally totally skip it as well. You can directly jump onto the code part when I do how hash maps function in Java. This is just for general knowledge. Okay. Why? Because here I can say, why is this like going to hit all the slots of the permutation if this thing is relatively prime to m? Because if I write the formula h1k plus I multiplied by h2k mod m, okay, this I can say is actually equal to h1k plus j multiplied by h2k mod m, and here I can say this means m divides I minus j. Okay, so for example, here I can say that m is equal to, let's say, 2 raised to power r. So if you make the second key always odd. So for example, size of the array, let's say 2 raised to power 4, which is equal to 16, then h2 of k can be equal to 5. Okay, so I would say don't worry much about this thing. This was a little extra thing. I'd say you can skip it. It's fine. No one will ask you that much in detail about how double hashing works internally. No one will ask you about double hashing either way. But if I talk about like the hashing function, let me just tell you one other last important one before we move on to the code. This is uniform hashing assumption. It is not same as the simple uniform hashing that I looked really. So the assumption is that every key is equally likely to have m factorial permutations as the probe sequence. Okay, because there are m elements, so how many sequences can a key have? First it will try this one, then this array, then this one, this one, this one, this one, this one, this one, this one. So there are many sequences. First it is trying index number 3, 4, 5, 8, 1, 2, like that's a permutation. So how many total permutations can it have? M factorial. So the assumption now we are making is that every key is equally like to have m factorial permutations. Okay, so let's say you use open addressing to insert n items into a table of size m, right? So under the uniform hashing assumption, I can say that the cost of the next operation, okay, is going to be equal to cost of next operation is going to be less than equal to 1 upon 1 minus alpha. I will explain this in just a minute how that is possible. Because as alpha grows, the number of expected probes that you need will also grow. Means that we will resize the table. For example, when alpha becomes high, so we'll try to keep alpha small. Okay, so for example, I can say that, okay, we all know what alpha is, load factor, n divided by m, which is always equal less than 1. So if I say alpha is equal to 90%, let's say 90% it is full, then I can have 10 expected probes. Okay. If you want to look at a proof, like I know what this sound, Kunal, how did you just put this random number 1 upon 1 minus alpha? Let's take a look. Okay, let me explain to you the cost of next operation, how it's coming this. So, how do we do it? So let's say you want to insert an item with a key k, and let's say that item is not in the table. What is the probability that the very first element that it finds will be the empty element? Let's say there are total m slots, n you have already inserted, then how many are the empty slots? M minus n. First success chances, because we are assuming that everyone has an equally likely chance. Let's say this is equal to probability p. If the first one fails, then the second success is equal to what? Remaining slots minus that current slot. Total minus 1. Out of total minus 1. This is obviously, I know, greater than equal to what? M minus n upon m. And I know this is equal to p. Right? So p comes out to be what? 1 upon n minus m, which is equal to 1 minus alpha. Sounds good? So with every trial, I can say for the next trial, if we want to do third success, for example, right? M minus n divided by m minus 2, which is also greater than equal to p. Right? So this probability p is coming out to be, so as the number of operations increase, that will always be equal to greater than equal to p, and p is equal to what? 1 minus alpha. So in mathematics, when you want to get the expected number of trials using a probability, you just have to reverse it. So expected trials comes out to be 1 upon p, which is equal to 1 upon 1 minus alpha. This thing. So this is the cost of next operation. Okay, how many operations it will take for next item. Okay. Similarly, delete will also take O of 1 upon 1 minus alpha. Sorry, my notes are a little messy, but the important thing is the video keeps going. Okay, so this is the expected number of trial for success. Okay, that's open addressing. I hope this one was clear. So very simple stuff, not much complicated. Just try to think what we're doing over here, everything I've written on the board. But now, the real question is open addressing versus the chaining that we did previously. So when to use which? Open addressing, better cache performance. If someone asks you in interview, better cache performance, like better memory usage, because pointers are not needed. Pointers not needed. And chaining when this is less sensitive to hash functions, because open addressing requires some extra care to avoid clustering and the load factor. For example, open addressing degrades past 70% because the array is full now. Number of slots are getting smaller, like the number of slots. Yeah, sounds good. Cool. That was basically about it. We'll now look at Java and how you can do Java. You'll have more fun now because I know theory can be a little bit boring. But yeah, hashing being used in cryptographs as well. For example, when you store your password, you don't just store your password as a text, you convert it into a hash, then you store it and digital signatures and all sorts of things. You do it that way. But let's take a look at some code samples and some internal implementation of how these things work. We'll implement the chaining and stuff. But yeah, and also see what map Java offers inbuilt. So yeah, one more thing I want to tell you is that the items that are stored in the hash map are not in sorted order because it's getting random numbers. So it will be stored randomly. But I hope you understand how that works. Now let's take a look at Java. So in Java, there's this interface called map, and there's a set interface in Java also, which is like you can add collection of items with no duplicate elements, and you can get items in constant time, but there's no key value. Okay, just one item is there. So here's a hash set and linked hash set, tree set, so on and so forth. I'll show you the code in just a minute, but here you can see interface map. It has some implementing classes. In a map, the main ones we'll look at is HashMap. There's the linked HashMap. So for example, you can check out what the linked hash. So it has the hash table and linked list implementation than the one we just looked. Okay, so that one is there. It also has something that you might want to look at called tree map. Remember I told you that you can't store in sorted order, but in tree map, the items you store in the map are in sorted order. Okay, and this is a red and black tree based implementation. We have not done red and black trees right now, but we'll do it later on. But yeah, and also it's giving a note that it's not synchronized. So if multiple threads access the map concurrently, it will modify the structure. So if you want to use tree, if you want to use a map, but also want to keep items in sorted order, use tree map. It's very simple to use, like, because these are abstract data types, meaning it will just give you the methods like get, set, delete and things like that. And you don't have to worry about the internal implementation. Contains key, size, and get object, find the first key, last key, put all, put, remove, so on and so forth. So you don't have to worry about the internal implementation of tree map, but you can take a look at the Java code, but we'll take a look at as well. We'll also, obviously create our own implementation from scratch and everything. But yeah, the most popular one is HashMap. So you can see over here, simple key value pair, very simple stuff. And yeah, some of the methods are available over here. Let's say put key value, remove this key, and return a collection of values contained in the map, the size of the map you can get, so on and so forth, if it contains the key. So let's just look into that. So if I'm doing hash maps, if I'm just like zoom out a little bit, hope you can see. Here I can say hash map is equal to new. What I can do is I can add in a type, hash map of type string comma int, map dot put Kunal 989 Karan 99 Rahul, map.get marks of Karan. Oh, what is wrong with me today? 99. Okay, Karan's mark is saying 99. So it did not do any traversal or anything. It just gave me 99. Other functions you can try, it is entry set. Return a set of the view set. It will just return a set of the set view of the mappings contained in the map. Okay, you can get or default. That's another one. So you can either search for it. If it doesn't exist, then it will give you a default value. Okay, get or default. Get or default, let's say Apur is not in the database, so just give me 78 instead. See, 78. So just explore the documentation. Contains key, contains value. If it contains key, map dot, contains key Karan. Yes, it is true. It contains Karan. True. Easy. Is empty, key set, it will return all the keys. Similarly, you have set over here, right? You can have a hash set. So it is just a collection of items that are not duplicate. And okay, also you can access the items in constant time. So I can say, actually, let me just create function. Public no, never mind. I'll just do it like this. It's okay. This can be a hash set of integers. Okay. Hash set has add. So I can add and I can clear and I can return an iterator, so I can iterate upon it and I can get the size of this, so on and so forth. So set.add 56, set.add, I'll just try to add a bunch of things in it. Let's say I add 56 again, it will obviously not include it twice. See, no duplicates. 56 I inserted twice, but it will only give me once. Okay, hash set. We will see in future videos how we are utilizing hash map and hash set and everything. Similarly, you can use tree map, just convert it into a tree map. So internally it will be same way. Okay, internally it's same. Internally it's different, but the way you're using it is same. But tree map, now it's storing it in sorted order. Okay, so tree map, if you want to get items, it will also give you items in sorted order. Descending key set, return a reverse order navigable set view of the keys in the map. So you know object-oriented programming now, so you can explore, I'll just say explore all of these methods on your own. Easy stuff, not a problem. All the documentation, everything is given, right? But what I'm going to do is, this all is fine, but what we're going to do is we're going to do our own implementation. We're going to do our own implementation of hash maps. Okay, I'll try to do, let's say I'll do chaining using linked list. Okay, let's try to do that. Let's do our own implementation of hash maps. One more thing I wanted to mention here, you can see a hash map and hash table. So what is the difference between these two? The best way to find it is actually looking into it. So hash map, here I can say that hash map is not synchronized, so it is not thread safe and cannot be shared between many threads without using proper synchronization code, whereas hash table is synchronized. Okay, so all the things we learned about load factor and initial capacity, everything, default load factor 0.75, all the things, theory thing we did, you can already see over here. So we've done some pretty good so far in the lecture. Okay, also HashMap allows one null key and multiple null values, whereas HashTable does not allow any null key or value. And HashMap is basically preferred over HashTable if thread synchronization is not needed. Now I'm asking why HashTable does not allow null and HashMap does. Well, because if you want to successfully store and retrieve objects from a hash table, the objects used as keys must implement the hash code method and the equals method. Okay, since null is not an object, it cannot implement these methods. HashMap is basically an advanced version and improvement of HashTable, and HashMap was created later on, that is why it has this functionality. But that's the answer to the question why HashTable doesn't allow null, but HashMap does. It's all written in the documentation. I love reading documentation, you should as well. Okay, so I'll just do a simple implementation. This is obviously not very optimized, but just to explain to you, I can say not public, I can just say class map using hash. And here I will create a constructor. I'll actually just copy this so that I don't have to add in again and again. What I'm going to do is, internally it will be an array, entity type, entities, and I can say entities is equal to new entity array of, let's say, 100 elements for now. And what I'm going to do is I'm going to create an entity as well. So private class entity. This is going to have what? String. Every entity has what? Key and value. Constructor this dot key is equal to key. This dot value is equal to value. Okay, good enough, right? Now some basic methods we'll make. Let's say we can do put public void put string key string value. You can obviously use the the what do you call it? I forgot. The magic ones, the mixing Python with the Java. Wildcards, think, yeah. So wildcards in Java. Not wildcards. What is it called? the type that you can provide. Generic, right? It's known as generic. I have covered generics. Okay. Allow a type. Compile type safety. So generics in Java, you can use generics if you want. This is a proof that you don't have to always know everything. You can just Google, and that's how I showed you. People often ask me, Kunal, how do you know so many things? I don't. I forget stuff all the time, and I use Google, and that's okay. Because I never memorize like the syntax and the theory and keyword and parts and stuff like that. Basics always should be clear. But anyway, I want to put an item. How do we do that? we have to get the hash first. Math.absolute, I can say key dot hash code modulo the size of the array entities dot length. Okay, then entities of hash is equal to, I'll create a new entity. Obviously this is not good one because it is overriding, no chaining, nothing. If you find something that is same, it will override it. Okay, I can get, if I give it a key, I need to get that. So again, I will just get the hash, constant time, if entities of hash is not equal to null and entities of hash dot key dot equals the key that I'm searching for, return entities of hash dot value, otherwise return null. Okay, this check I added because there might be the case that you have removed that key. Speaking of which, I can remove a key also. I can again get the hash. After I get the hash, I will check. If entities of hash is not equal to null and the key is the one that I'm searching for, right? In that case, what am I going to do? I'm going to remove it. Simple but not very optimized. We just made our own hash map. Map using hash. Mango, king of fruits, map.put. Sweet red fruit, map.put. What's the spelling of lychee? Maybe that's it. Kunal's favorite fruit, map.get apple. In constant time, amortized constant time, it will give me the answer. Okay, so I will run this. Sweet red fruit, not a problem. But it's not very well optimized. Okay, sounds good? Cool. What I can do now is, instead of this, I can do linked list. So map using linked list. Let's do that. Okay, so let's make it a little bit prettier and nicer. So I can say HashMap separate chain, or I can just say smaller name. I can say HashMap final. Okay. So internal implementation, we will have around using linked list and stuff. HashMap final. Let's try to make it using generics. So I will add in key comma value. All right, sounds good. We will have an array list of linked list of type entity. So every element in the array list or the array that I have will be a linked list, and that linked list will have types of entity, right? And the entity I can copy. It's the same as here. Private class entity. Okay, so private class entity, I can hide this so that you can see it clearly, string key value and the simple stuff. All right, that looks good. Actually, I'm going to put it inside. Nice, now looks good. What are we going to do now? I'm going to have an initial size. I can say private int size is equal to initially 0, and I will have a load factor. Private float load factor is 0.5 float. So it means that 0.5, we all know what this means, load factors, inserted items divided by the total size of the array. So for example, if you need to add 100 items and you have already added 50 items, then if you add the 51st item, it is going to double the size. Copy the all elements, then add in the 51st item. Amortized constant time. The same thing we did in theory. Okay. I'll create a constructor. Right? Gonna create a list, new array list. And I can say for int I is equal to 0, I is less than 10, I plus plus, let's say the initial size. I can say list.add new linked list. Okay, initially let's say I've added 10 empty linked lists. Okay, so far we have done nothing, we have just set some stuff in. But the main part is if I want to add an element, public void put k key value, I will just get the hash key dot hash code modulo list dot size. Okay, and I will say linked list of type entity. So you have a particular element and let's say you want to insert that element. You have got an element, let's say Kunal, you've got the number, so you need to get this linked list first. So you will go to the overall array lists, that index, it will give you a linked list of type entity. So linked list of type entity is equal to, in the main list dot get that index. Now you have that index. Now try to search for these entity. You can say for entity in entities. I can say if entity dot key dot equals the key that I have provided. You can say entity dot value, means you can update it, is equal to value and then return. Okay, entities dot add, you can say new entity key comma value. But before adding I have to check the load factor. If float of size divided by list dot size, so current elements that I have added divided by list dot size, if this is greater than the load factor, then rehash, means double the list, and whenever you add you also do size plus plus. Okay, so double the list. So how do we do rehash? Rehash is very simple. I hope you're able to understand because I'm only doing the things that I did in the theory. So now we are rehashing. I can just say system.out.println. We are now rehashing, and I can say that okay, let's say this array is full, So sorry, these are 50% full. So I will copy every single linked list at every single index into a new array list of double the size. Okay. Array list of type linked list of type entity old is equal to list, and I can say list is equal to new array list, size let's say initially 0, and I can say copy all the previous elements for int I is equal to 0, I is less than old dot size multiplied by 2 and I plus plus. So I will just say list dot add new linked list. Okay, so what I did was I just saved the old list in another variable, and I just created the new list, and that size of that new list is currently empty, but it is double the size of the previous list. Now I will just take every element from the previous list and add it in the new list. So I can say for every linked list in the previous list, and every entry in that list, just insert it. So accordingly it will do the hash functions and everything, and it will insert it. Okay, very easy, simple stuff. Now similarly I can say public value get, pass a key, it will give you the value. I need the hash, so I will calculate the hash. Here you go. Actually put it here. Okay, got the hash value. Linked list of type entity is equal to list dot get at that index, and now in that index of the array you have a linked list. So at that index you have a linked list, and try to search if the answer you want, the key that you want, is in this linked list or not. If entity dot key dot equals the key that you are searching for, then return the value. Otherwise it is not found, return null. Okay, sounds good. Similarly I can create a remove, public void remove key. You can also return the value over here if you want. Int hash calculates entities is equal to list dot hash, got it. Target entity is initially, let's say, null. For entity, in entities, like all, I'm just gonna, similarly I was searching, I will searches again. If I found it, then I can say I have found it. Target is equal to entity, break, entities dot remove target, and also don't forget to do size minus minus. That's it. Pretty simple stuff. You can also make other functions like contains key or not, public boolean contains key. I can say return get key is not equal to null. Okay, so that is return true if you found the key, otherwise return false. Okay. Similarly, if you want to, how we did just print the object. So if I say HashMap final map is equal to new HashMap final, and I try to print that map, first of all it will give me some gibberish value, but I can do that, I can fix that by overriding the toString method. I've covered this entire use case in object-oriented programming. How to pretty print objects, custom objects that I have built, how to pretty print those using the override function, the override annotation. I'm not going to explain the override one because I've done it in detail. How to pretty print objects, I have done it in detail in the object-oriented programming playlist. And please don't ask me what override means. So string builder is equal to new string builder dot append. Let's say my array will start if my output will start with closing brackets, my output will end with this, and then I can say for linked list type entities in the main list, and for every entity in that list, builder dot append, I can say entry dot key, and I can say builder dot append equals entry dot value, and also then append a comma. Simple. That's it. Created our own hash map with linked list, generic, all those terms that we learned as well. Very simple. So we did a lot of stuff. Don't worry about it. You can run this using this, like just go to the main function, run it. It's pretty straightforward. But thanks a lot for watching. I'd say if you like this video, make sure you like, share and subscribe. In the next videos we'll do some more questions. If you have any questions, leave those in the comment section below, but still I'll run this before we wrap up. One mistake I made while copy pasting is this should be of type K, type V, type K and type V. Okay, to fixing some typos, I can go to my main, I can say HashMap final, and it should print a sweet red fruit. Cool. Similarly, what I can do is I can just print the map as well. Run. See, lychee, Kunal's favorite fruit, comma mango, Kunal, king of fruit, comma apple, a sweet red fruit. There you go. Because of the overriding the toString method. Okay, start with this, end with this, added this. So when you print an object directly, just a reminder, it will look at the toString method, and because of the hierarchy, it will first look at the overridden one. Why am I explaining? Just go watch the object-oriented programming playlist. But that's basically about it. And yeah, make sure you like, share and subscribe. Leave the comments. Comment helps as well. And you can take a screenshot, share it on socials using hashtag DSA with Kunal. Share what you learned about Hashmaps. Share your journey. Join the Learning Public Initiative, assignments, code, everything can be found in the description below. If you want to run this code directly like I'm running, just using this browser, I will leave it in the description below so you can check out the URL, and I will update the assignments and stuff after I'm done. The next few videos will be around around questions, interview questions, and some other concepts that utilize hash maps. So we'll do that. But yeah, I'm looking forward to seeing your learning journey, and yeah, any questions or any appreciation, let me know in the comment section below, and check out the links in the description and the previous DSA videos that I've done and other boot camps, and I'll see you in the next one. Have a great day.